Hello everyone. I thought I would give some help on a question. I had a person emailed me about some confusion with this question number 4 in the first distribution quiz. And I thought I'd take a moment to clarify it, mostly because it's a really important concept that you need to grasp. And I have reworded it a little bit to maybe help get over some of the confusion that was originally thought. So the question is, suppose you develop a test for gender based on height. You decide that if you are shorter than normal height for males, you are likely to be female. You decide the criteria for a normal male is mean minus 2 standard deviations. In other words, you're 2 standard deviations out from the mean of the height of male going in the negative direction, because women generally tend to be shorter than men. That happens to be the answer to the second question of these 5 questions on this quiz. So the question then is, what percentage of women are taller than this criterion and thus predicted to be male? And now here's the important part. Use the table from slide 9 to compute the answer. So let's look at our slides here. And first, let's get it. This is slide 9, and it has a table in here that's very useful for you. Really need to do it. Use that. So what is our, let's just review this particular table in this slide. So we had a situation where this green or bluish line is the distribution of males. So the mean is around 71, and 2 standard deviations is right about there. So you're down to about 2.5% of the males falling below this. So you use this as a cutoff and saying that if you're below this line, you're likely to be female. And this is a silly example for gender selection, but it's a common method that is used in somewhat of a common misconception. You figure if you're outside of normal, then that's the test. And it's true if you're going that way. The problem is it's not true if you're above 2. So if you're above 2 standard deviations out, there is a certain pretty good probability that you are in fact female. And in fact, it's this amount of people. It's not this tiny little amount, it's this big amount. That if you say you are height greater than 66 inches, then you are going to be male, when in fact there's this big chunk. So let's just kind of review. The male mean was 71.1. The male standard deviation was 2.46. If you take 71 minus 2 times 2.46, you get 66.18. Now is where we use table 9, or slide 9. And just take a look at this whole thing here. So we are at males of 66. You can see there's not very many males less than 66. There's only really one in this particular observation. There's more when we simulate and get the whole population rather than just this little sample. But so we come down to females and we find 66. And we look over here and we see that this is the cumulative percent. So it starts small, the shortest person, there's 1, it's 1.2%. Then add 2 more and you're at 3.6, and then 6, and so forth, up to a height of 66 inches. So if you're at the male cutoff of 66, then 68.7% of women are shorter than 68.7% of the population. So then we have 2 ways of going. We could add all the percentages, 67, 68, 69 inches, 70 inches, 1.2, 1.2. And this sum is all the people, all the women that are taller than 66 inches, and that's the percentage that will be misclassified if you say you're taller than 66, you're a male. So it's really not a good idea to do that. But the other way you can get it is the cumulative percentage accounts for 100%. Well, you know 68.7 is here, so 100 minus 68.7 gives you the answer, about 31%. So the answer to the question is 31% of women would be considered male if we used this 66 cutoff point. So I just wanted to clarify that. We're going to see in the next video, we're going to do an example with IOP, and you'll see this is a common way of setting up a test. 2 standard deviations from the mean of normal is the cutoff for normal. And that's true. If you're 2 standards out, then you're probably not normal. But the inverse is not true. That if you're less than that, you are not, by definition, normal necessarily. You could be in the other population as well. All right, I just wanted to take a moment to clarify that and give a little information.